lesson 8 to 9 and 11 to 12. Okay, both hours we're going to do this as 7.2. So let's look at the notes for chapter 7.2. If you want to record anything, you want to jot down anything, you may do so. All right. So in this chapter, in this subtopic, we are going to combine all um, the terms, okay, the calculations you have learned in chapter 7.1. So the learning outcome will be to be able to describe the titration process. And also you want to distinguish the differences between the endpoint and the equivalence point. And then we want to sketch and interpret the variations of pH against the titrated value for titration. So there is three set of titration that you're going to learn. The first one is between strong acid and strong base. And then the second one will be strong acid, weak base, and then weak acid, strong base. Okay, bear in mind that we only have three combinations, and we don't have the combinations between weak acid and weak base. All right, and then the last one is to identify a suitable indicator for the titrations process. Okay, so for three set lah, you need to identify the suitable indicator. So basically, your acid-base titration is a process or a method, okay, to determine concentrations of an unknown solution. So one of the solutions, it will have an unknown concentration. Okay, and then another solutions with a non-concentrations is used to get the concentrations of the unknown solution. Okay, and the non-concentration solutions will be known as the standard solution. So this is the process titration. And of course, you have learned already acid base, is a neutralization process. Okay, so in the diagrams over here is just to show you the setup of experiment. So on the top over here, you can see we have a burette. Okay, and then at the bottom over here, you have the conical flask. So recall that in our previous lesson, you learned about the solution content inside burette is what we know as the titrant. Okay, ignore the bottom one. Okay, you just need to understand what is called in the solution in burette and also for the solution inside conical flask. Okay, whereby the solution content inside your conical flask is what we know as the analyte. Titrant is another word to indicate analyte, but in this case, to avoid confusions, you just use analyte. Okay, you just use analyte. So analyte refer to the solution inside conical flask, so sitting at the bottom. Okay, so at the bottom over here, you just ignore about the description. Okay, so can you follow until this part? Just to double check if you can follow. Is everyone all right?
Yes. Can.
Okay. Right. So titrant solutions in burette, analyte solutions in conical flask. So the next thing we want to look at is what is mean by equivalence point and point. Of course, in your experiment 2 and 3, you have already go through the definition, but let's revise it again. So equivalence point is the point at which a reaction is completed. So that means the amount of acid and amount of base has completely reacted. Okay, according to the stoichiometry ratio in the balance equation. Okay, if one more HCl will react totally with one more NaOH and etc. Okay, so at this point, you need to remember that no more acid or base is remain in the solution. So acid base will create or produce salt and water. So at equivalence point, no more acid and base. So what is remains inside your solution at this point? Can I know that? If no more acid and bases remain, so at this point, what do you contain inside the solution?
Salt and water.
Salt and water. Please remember at equivalence point, when all acid and base have been reacted, the solutions now is just your salt solution. So if you want to find the pH value at this point, or you want to find the pH value, it will depends on the salt. Since H2O is neutral. Okay, so the pH value at equivalence point will depend on the salt. So in chapter 7.1, you learn about neutral salt, basic salt, acidic salt. So it will use at this point. Okay, so this is equivalence point. But the endpoint is slightly closer to equivalence point. Now, endpoint is a point where uh, the indicator that you added into the solution. So normally indicator will added inside your conical flask straight away. So it want to show you color changes. So endpoint show the color changes. Why do we say endpoint and equivalence point is very close together? Equivalence point, no more acid or base, but the endpoint, it will having a slightly more acid or base or slightly more titrate. Therefore, you will see the color change. Okay, but it's very close to equivalence point. It just want to show you the color. It just want to show when the reactions stop. Okay, but your titration will stop at the endpoint. Titration will show at the endpoint when you see color changes. You're unable to stop at equivalence point because no color change. You cannot see anything. Okay, so at this endpoint, you need to select a suitable indicator so that you can see an obvious color change. So suitable indicator, the endpoint lies within the pH range. So this indicator will change color when the pH value fall within the pH range. Okay, and I want you to highlight something, which is the steep portion of the titration curve. So maybe you will ask, Madam, how am I going to know that where is my pH range? If for the combination between strong acid, strong base, strong acid, weak base, and etc. So you look at this steep portion, okay, inside titration curve. We'll look at this one in a while. So until this point, is there any questions? Are you clear about titrant, analyte, equivalence point, endpoint? That is what, Len?
Dạ được madam.
Okay. If no questions, then we proceed to the next. It's kind of like concept theory lah before you do the example questions. Okay, so the next one we want to look at is the indicator. Actually, what is an indicator? Now, why does it change color? So indicator is made up of weak organic acid. It's actually a weak organic acid. So when it react with the content inside your conical flask, it become the conjugate base, but it will not affect the acid and base originally inside the conical flask. Or it's just the indicator that will change color. When you have more acid or more base, it will show you the color. Okay, so a weak organic acid that has different color than its conjugate base. So it's commonly used to indicate the equivalence point by its color changes. Okay, it want to show you at which one is the equivalence point. Remember the endpoint very close to the equivalence point. So it want to show you where exactly is the equivalence point. Okay, so this acid-base indicator has its own pH range. Therefore, you need to choose wisely. And look at the table down below over here. You have a list of indicators. Thymo blue, you have a pH range 1.2 to 2.8. So it's very acidic. Okay, and then you have bromophenol blue, methyl orange, methyl red. The common one that we use is phenolphthalein. Okay, normally you use HCl and NaOH, we use phenolphthalein. So you will see a colorless solution when we add it into the acid. But when it is the endpoint, okay, you have slightly more base in the solution, then it will change pale pink color. So the pH range fall within 8.3 to 10 pH. Okay, the other common one we use will be methyl red, methyl orange. the one that we are using in the lab. Okay, but of course the other list over here you can also use it. Depends on what is the range. So for example, if let's say lah, the titration between a strong acid, strong base, we know the pH will be at 7, neutral salt. So you can use uh, bromothymol blue actually, because it's close by to 7. You can also use phenolphthalein because you added slightly more base, so it's within that range. Okay, so madam will give you a list for different combination. What is the suitable indicator? Then you can memorize lah from there. Okay. Then the next one we want to look at the pH range. So the range in which indicator change color mentioned before. And then this pH range at equivalence point is determined from the steep vertical portion in your titration curve, also mentioned in the previous page. Okay, in some reference book or maybe some of the references you find online, it will say this one is the pH jump. So pH range, pH jump is the same. So it has a specific range. Okay, it has a specific range for you. So this is just the definition. And the next page we want to look at, if you look at your notes, the next page will be the type of titration curve. This one will leave it until the end. Okay, this one will leave it until the end. So I want you to look at the guideline first. Okay, can you find this page? The guideline to sketch a titration curve.
Hold on, madam.
It's just the next page after type of titration curve.
Oh, page 4. Alright.
Okay. Dapat yang lain?
Dapat, madam.
Dapat.
Okay, so table 2, madam, hold on dulu. We see the guideline first. Okay. So I will go through the guideline with you and then we try some example questions. So for this guideline is for us to combine all the informations in order to sketch a complete titration curve. So the first step, of course, you need to identify which is the analyte, which is the titrant. So again, analyte in the conical flask, titrant in the burette. Second step, we want to determine initial pH. When we say initial pH, that means which one are we looking at? Is it analyte or titrant? Initial pH, if you still recall that the diagram, titration, we have burette, we have conical flask. So initial pH will depends only on the conical flask before you start the titration. And it is pure analyte. So in this case, you need to depend on analyte if it is a strong species, strong acid or strong base. We know that strong species will dissociate completely to give you H plus or OH minus. Then straight away you can find the pH or POH. Okay, so in this case you just apply lah. For example, if let's say you have a strong acid HCl, then the concentration HCl equals to H plus, then you apply straight away POH equals to negative log concentration H plus. So this is a strong species. But if you have a weak species initially, then you have to draw ice table. Okay, because weak species will dissociate only partially. Okay, therefore you need to use ice table. Okay, from ice table, what do you find? Why are we going to use ice table for weak species? A little bit of recap, huh? Anyone? For ice table, what can you see? What can you find? Masih ingat lagi tak weak species? Tak ada. Tak ada orang tahu. Kalau weak species, biasanya awak lukis ice table, apa yang awak buat? What do you do? Hmm. No answer? Where's this one?
Find number of moles.
Find number of mole. No. Kalau weak acids, kita pakai ice table. Dalam ice table itu kita akan pakai concentration. Since it's partial dissociation, ingat tak awak punya equation adalah equilibrium. Ada reversible error. So from there, you'll need to apply Ka expression or Kb expression. Okay, lepas tu awak akan carikan X. Find the X from your quadratic equation. So this X, either it will be the same as the H plus or the OH minus. Then only you are able to find the pH or POH. So kalau dapat weak species, memang kena ikut cara macam mana nak carikan pH value untuk weak species. But if you get the strong one, that will be straightforward. Okay. So this is step number 2, initial pH. Then in our step 3, you need to determine pH at equivalence point. So just now remember that Madam say at equivalence point, no more acid or base. What we can use is just the salt. So you have to determine what is the type of salt produced. Okay. So pH based on the salt produced, therefore you need to do the salt hydrolysis. And then we need to find the volume of titrant added. Okay, using the stoichiometry ratio of your balance equation. Then indicate the pH jump. So the pH jump over here is just a guideline for you. If it's strong base, strong acid titration, pH value will be within this one. So that means this pH jumps refer to the steep portion in your titration curve. 3 to 11, a rough range. Okay, and then if it is strong acid with base, the pH value will be lower than 7. So pH 3 until pH 7. But when you have the combination with acid strong base, the pH jump, your steep portion, will be within pH 7 to pH 11. So slightly basic, more than 7. Okay, so we will look at the example question in a while. And then after the pH value at equivalence point, then you have your step 4. Determine the final pH. Similar like step 2, depends what is the species, strong or weak. But at this point, final pH will depend on titrant. Okay, so strong acid, straightforward. Weak acid, your ice table. Then after you gather all the information, now we have 4 informations over here, yeah? Initial pH, pH at equivalence point, volume at equivalence point, and final pH. Then we can draw your titration curve. Okay, so this titration curve, the y-axis is pH. The x-axis will be volume of titrate. Of course, you need to write the formula for titrate. Okay, and then label pH at equivalence point. Label the volume of titrate. And lastly, if it is the combinations between a weak species and a strong species, you need to label buffer region. Okay, so at the bracket over here, if any. So it means that if it's combination between strong acid, strong base, no buffer region. But if it's between weak and strong, there will be buffer region. Okay, so what is a buffer region? It's actually the same thing as buffer solution. Buffer region refer to the mixture that contain only weak acid or base with the salt that containing their conjugate pair. So is it acidic buffer or basic buffer? So until this point, is everyone okay? Ada soalan nak tanya step 1 until step 5? Do you have any questions to ask? Tak ada So kita cuba soalan yang pertama. Okay, we start with the easier example. Okay, you do it together with Madam, yeah? Ready?
Ready.
Ready. Okay. So questions number 1 give you 25 milliliters of 0.1 molar HCl is titrated with 0.2 molar NaOH. So at this point, we need to identify your analyte and titrant. Okay. So there's two ways you can identify. The first is to read the question, to identify the sentence. Analyte is titrated with titrant. Titrated with. So the behind this one will be your titrant. So depends on what is your titrant. So in this case, HCl is the analyte, titrant is your NaOH. Or sometimes the sentence would say like this, is titrated against. So the front part will be your analyte. Analyte is titrated with titrant. Okay, that is the first tips you can identify analyte and titrant. The second tip is, in a conical flask, we contain 25 milliliter. If this 25 milliliter is fixed, dia tak ada berubah dan dia memang bagi 25 milliliters. So that means that solution will be inside conical flask. 25 milliliter will be inside conical flask. So that will be your analyte. Ada dua cara boleh kenal analyte ataupun titrant. So once you identify analyte and titrant, then only we proceed to the calculations part. Can you follow? Dia boleh tukar, dia boleh tukar. It can say that NaOH is titrated with HCl. Can also, not necessarily HCl is in the conical flask. It can change position. So you need to read the questions properly. All right. And then step 2, to calculate initial pH. Again, this one depends on analyte, which is our HCl. So HCl is a strong acid. So concentration of HCl is the same as H+. Therefore, we use it straight away, 0.1 molar. Then apply into your formula, pH equals to negative log concentration H+. Then you will get the pH value of this HCl, which is equals to 1.0. Okay, is that clear until step 2?
Yeah.
Okay. Then we proceed to our step 3, pH value at equivalence point. Okay, there's two things to find in step 3. First of all is the pH value. So this pH value at equivalence point similar like our salt. Either you want to find it pH more than 7, pH equals to 7, or pH less than 7. So of course you can identify strong acid, strong base produce neutral salt. So we will get a pH equals to 7 at equivalence point. But of course you need to explain. Okay, and then the second one, it will be the volume of titrant. Okay, volume of our NaOH, the titrant. So write out the equation for neutralization. We have HCl aqueous. We have NaOH aqueous. So neutralization is complete reaction. So it will produce NaCl aqueous and also our H2O liquid. So over here, you can see the salt. At equivalence point, no more acid and base. So it will depend on the pH of your salt. Okay, so we write the dissociations of the salt NaCl. aqueous. Why we say aqueous? Because NaCl is a soluble salt. It's a clear solution. So it will dissociate completely to give you Na plus and Cl minus. So both Na plus, Cl minus, they are from strong species. Therefore, they will not hydrolyze in water. If both species cannot be hydrolyzed, then we have to use the auto-ionizations of water. So recall back our three equations: neutralization, dissociations of salt, and hydrolysis. So in this case, the hydrolysis refer to the auto-ionizations of water. So this one is for you to revise back analysis of salt. Okay, so auto-ionizations of water give you same concentrations for H plus and OH minus. Therefore, pH equals to 7. Is everyone okay?
Yes, madam.
Alright, so the next one we want to look at is the volume of titrant. Again, which one is your titrant? HCl or NaOH?
NaOH.
NaOH.
NaOH. Okay. So you may use the formula or stoichiometric ratios to calculate this volume. So first one, if you want to use formula. Okay, please copy this formula over here. MAVA, A stands for acid, and BVB, B stands for base, equals to A over B. Okay, so this A over B, the ratio is getting from your balance equation. For this one. Okay, so for this A and B is refer back to your stoichiometric ratio equation. Okay, and then we just substitute the value. What is the concentrations of our acid in your questions? 0.
0.1 molar.
How about the volume for the acid?
25 now.
25. Okay, concentrations of the NaOH also given in the questions, which is 0.2. So we want to figure out your volume of the base. And then A over B, it has a ratio 1 over 1. So in this case, let madam know what is your volume of NaOH.
Twelve point five milliliter.
Okay, 12.5. Is everyone getting this value? Dapat jawapan ni tak?
Dapat.
Okay. So ini salah satu cara nak guna formula. Another way is to use stoichiometric ratio. Okay. So if we figure out the number of mole of HCl, 0.1 times 0.025, which give you 0.025 mole. This one is concentrations times with the volume in liter. And then if you look at the ratio, 1 mole HCl will react with 1 mole of NaOH. Therefore, number of mole of NaOH is equals to 0.0025 mole. Then you apply the concentrations and equals to N over V. Then figure out the volume. Volume still will be the same. Okay. So the answer, the volume will still be the same. So using 0.025 divide by 0.2, which give you 12. In this case, because you're using liter, right? So over here, you will get 0.0125 liter. But then, of course, you can convert into milliliter. So either way, you want to use stoichiometry or formula. Formula is quite straightforward, but you just need to take care about the ratio. Okay. Boleh catatlah kedua-dua cara. So in case you want to use either one. Okay? Sampai sini semua boleh ikut? Is that very
Boleh,
clear?
madam.
Boleh, ya.
Yes,
Simple.
madam.
Okay. So, step 4. How am I going to do it? Step 4 nak buat macam mana? Kita carikan concentration OH minus since sodium hydroxide is a strong base. Okay, so it will follow the concentrations of the NaOH given. And then we figure out the POH equals to negative log concentration OH minus. Okay, try to calculate on your own. Tell me about the value of pH. Cuba kirakan dapat value berapa pH?
13.3.
13.3, agree. Yang lain agree.
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 Okay.
Agree.
So pH value equals to 13.3. Jadi cuba nak awak practice kan. Walaupun dia nampak senang kan. Sebab kita nanti nak combinekan semua. Okay, we want to combine all the information in one curve. So the last step is to ini yang last step. Jadi step. So the last step here, we want to sketch and label your titration curve. So the y-axis is your pH. The x-axis is volume of titrate. So in this case, titrate is your NaOH. Don't forget unit, milliliter. Nak pakai liter pun boleh, tak ada masalah. Okay. So our initial pH is before adding any titrant. So bila volume NaOH kosong, that means it is initial. So initial pH from your calculation is 1.0 or depends on the analyte HCl. Okay, so kita pangkallah dekat sini satu point. Okay, what is your pH value at equivalence point? So just now you have already identified, right? So what is the pH?
7.
pH equals 7. Okay, so madam draw it over here. pH equals to 7 at equivalent. Volume untuk equivalence point? How about the volume? What will be the volume?
12.5.
12.5. Okay, so 12.5 at this point. And the last point, your final pH depends on titrant, and we have 13.3.
3.
Okay, then you can label your, so 13.3, of course, the volume of your titrant will be a lot, will be more than the acid. Okay, so we need to sketch a curve, then you link it up the point. Okay, so we will see a steep portions over here, and then finally it reaching the final pH. So this is the titration curve. If you have the analyte strong acid, you have the titrant strong base. So this is what we call as the steep portion. Dekat sini adalah awak punya steep portion or the pH range, pH jump. Dia tak ada mesti kena tepat kita turn dekat mana, tak ada. Asalkan awak nampak satu curve like this. Is everyone getting it? You get the idea?
Yes, madam.
Yes.
Boleh ikut Okay. So now we try. If without calculations, can you identify or not the curve? Okay, so untuk dua soalan ini, okay, question 2, question 3, madam will explain in the next hour, 11. Okay, so madam will show you question 2, question 3 together with the exercises here at 11. So now go to the previous page, which you have this table. All right, so at this page, it show you different titration curves. So altogether, you have 6 curves. Okay, you have 6 curves. So there's the titration. The first one, the first combination, titrations between strong acid and strong base. So given in the list here, you have the indicator. You can choose phenolphthalein, crystal red, methyl orange, methyl red, chlorophenol blue, bromophenol blue, but except thymol blue. Because thymol blue, the pH range is very acidic. It's just until 2.8, so it's not suitable. Tapi yang lain boleh pakai. Okay, the rest of it can use it. So just now, if you still remember in Madam's guideline, it said that for the combination strong acid, strong base, the pH range is from 3 to 11. So it's a guideline for you, 3 to 11, the pH range for strong and strong species. So this is what we just now use it. This is the curve just now we draw. Strong acid against strong base, analyte against titrant. So in this case, analyte is your strong acid. Okay, and just use the short form SA, indicate strong acid. Then the titrant is your strong base, SP. Okay, and then you will see initial pH very low. Okay, a low pH indicate the strong acid. Then the equivalence point, pH equals to 7 for neutral salt. And then indicate what is your volume. And then when the titration is still going on, you adding more strong base. So the pH value will getting close to this 13.3. So let's say just now we have 13.3. So the pH value will getting close to the titrant, but not yet touching. Because in the solutions now is containing strong base with the salt. So it will close by, get close by, but not entirely 13.3, maybe 13.299999. Okay? Can you understand this one? Betul? Boleh. So yang lain awak kena sketch. So kalau Madam tukar positions dia. Strong base against strong acid. That means strong base is your analyte titrant. Strong base against strong acid. Analyte is strong base or strong acid?
Analyte.
Strong base.
Strong base. Strong base is your analyte. Then against titrant, titrants will be your strong acid. So that means the initial pH, so this is volume of your, tulis dulu volume of titrate. So in this case, is your strong acid. Okay, so initial pH depends on analyte. So your strong base has a higher value of pH. So it will start over here. So let's say Madam follow the pH value at follow just now, 13.3. Okay, and then at equivalent point, still you are going to get pH equals to 7. But maybe we just don't know about the volume lah. We don't know about the volume. But no problem, you can just plot it in the middle of the curve. Okay, and then the final pH will depend on the titrant, strong acid. So dari sini kita boleh draw curve dah. Walaupun dia tak ada information, right? We still can identify from the types of acid and base. All right, so this is the titration curve if you have analyte as the strong base, titrants for the strong acid. So it will be inverted. Okay, the curve will be terbalik lah. Depends which one is your analyte and titrant. So sampai sini boleh ikut tak? Boleh faham tak?
Boleh, Madam.
Okay, so it will be the best if you get strong acid and strong base, both strong species. But when it enters strong acid and weak base, So let's look at the second combination. Okay, so this is the titration between strong acid, weak base. So madam just want to know what is the type of salt produced from this combination? What will be the salt? Is it acidic salt or basic salt?
Acidic.
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 Because you have a strong acid, isn't it? So it will produce an acidic salt. And try to tell me about the pH range. Less than 7, more than 7, equal 7?
Less than 7.
Less than 7, very good. Okay, so acidic salt at equivalence point, and then pH value should be less than 7. You don't need exact value pH for equivalence point, just the range. Okay, so for this case, strong acid against weak base. So analyte is your strong acid. Okay, titrant is your weak base. SA stands for strong acid, WB stands for weak base. So initially, pH depends on your analyte. So it has a very low pH value since it's a strong acid. So let's say this one is 1.0. Okay, so when you added weak base, the pH value slightly increases until you reach this equivalence point. But because now at equivalent point, what contained inside the solution is just the salt and water. So acidic salt pH value lower than 7. So when you keep on adding your weak base, okay, the pH value will still increase. But if you realize this point is no more 13.3, because you are adding weak base, the pH value will be slightly lower. Say if we have 11.5, example. Okay, so weak base pH value is slightly lower. So that means the whole graph, the whole curve will move slightly lower. Will move slightly lower. So at this point, madam give you choices. Tempat yang madam highlight dekat sini Okay, ada dua tempat kan? So madam bagi awak pilih. Ini adalah region A, ini adalah region B. So which is the buffer region? You can type in the message column which one is your buffer region, A or B. Buffer region, that means in a buffer solution containing weak species and the salt. So which one do you think is a buffer region? All right, very good. It will be B. Okay, why do we say so? If you look at A, over here, we containing at this region, at region A, you are containing HCl and slightly the salt. Since the added weak base is completely neutralized by the strong acid. Acid behave as the excess reactant. Therefore, combination strong acid and the salt is not your buffer. But then in this region, this will be your buffer region because after equivalence point, no more acid, but there is salt and water. Okay, and then you keep on adding the titrant, and the titrant is weak base. So at this point, at this blue color region, the buffer region, containing salt and the weak base. So actually, you are containing a basic buffer at this point. Salt plus weak base give you buffer solution. So every time we see a combination weak and strong, there will be buffer region and you must label it. Okay, soalan ni popular lah. Kalau dalam objektif memang dia akan keluar. Memang tak ada lah. Tak ada guarantee lah, tapi better you learn it first. Okay. And then let's look at the next example if we change the position. Okay, weak base against strong acid. So weak base is it analyte or titrant? Weak base is it analyte or titrant?
Analyte.
Analyte.
And then strong acid will be your titrant. So again, pH against volume of titration. So in this case, titration is your strong acid. So it will start with the initial pH. Say we start from 11.5, similarly. So when you added the strong acid, the curve go this way. And the equivalence point, pH will be less than 7 still. Though the final pH depends only on the strong acid. Strong acid has a very low pH value. Okay, so similarly, we need to identify your buffer region. So initially, we have the weak base. When you added strong acid, it will completely neutralize. So the region, the buffer region, will be at this point. Since you get excess weak base and you have a little bit of the salt. So this one will be your buffer region. After equivalence point, what contained over the curve over here is just salt and your strong acid. So it is not a buffer. So are you clear until this point?
Yes.
Boleh ikut boleh catat
Boleh.
Okay, so indicator also you can try to memorize a few. Meteorate, meteor orange, chlorophenol blue, bromophenol blue. So the last combinations we have here is titrations between weak acid and strong base. So the indicator is only these two lah. So you choose it wisely. Weak acid, strong base. So you tell me about the analyte for the first combination, weak acid, strong base. Analyte will be
Acid.
acid, titrate will be strong base. So initial pH depends on the weak acid. So if let's say Madam give you this one is 2.5. So slightly higher pH value for weak acid. So for this one, combination weak acid, strong base will give you a basic salt. Okay, give you a basic salt. So this basic salt pH value is more than 7. So we can predict the pH value at equivalence point. So pH will be more than 7. And then when you add more strong base, okay, it will proceed to the pH value of titrate. So in this case, 13.3. Okay, then we look at the buffer region then. Is it at the lower part or higher part is your buffer region? Before equivalence point or after?
Before.
Before. Since over here containing your weak acid and the product salt. Strong base added will be completely neutralized because you haven't reached the equivalence point yet. So must label it. This one is our buffer region. So similarly, if I change the position, strong base at the bottom. Okay, so strong base will be analyte. Weak acid will be my titrant. Okay, so this one will be pH against volume of weak acid. So we start with the pH value of strong base, your analyte, 13.3. So we go this way down until the bottom and the final pH 2.5. Depends on the analyte. Depends on the titrant. And then don't forget to label your equivalence point pH. It will be more than 7. And then if you have calculation, got information, then you will have this value. Okay. Buffer region, is it after the equivalence point or before? For the second curve here.
Before.
Is it before or after? Upper part or lower part? Sekejap ya, madam. So yeah, pH 7 ini adalah awak punya equivalence point. So this will be your equivalence point. So initially we have strong base. So until this part, this region, you have strong base and the salt. Is it a buffer?
No.
No. So it proceed until equivalence point. No more acid and base, but you have salt and water. Adding more weak base. So until this point, you got your weak acid and the salt. Weak acid and the basic salt. So it will be your buffer region. So very important lah to recognize the definitions of buffer solution. Nah, baru awak boleh nampak, okay, sebenarnya dalam solutions tu, apa yang ada. Okay, so refer back to your definitions of buffer solution. So here, altogether, you have 6 different graph. It depends on what is the combination. What is analyte, what is titrant? Strong acid or weak acid, strong base or weak base. So is there any problem for this part? Ada soalan nak tanya? Semua orang clear ya?
Yeah, madam.
Okay, if no problems, then madam send you the attendance link in the Google Meet here, yeah? Okay, so you can answer the assessment and fill in the form lah. So if no questions, kejap ya, madam tengok apa yang madam nak. Okay, so for the lesson at 11, we will do another few example. So the calculation for this one, general titration curve lah, and then we will also look at the specific one. So if you look at exercise 1 here, why you have a specific A, B, C, D, E. So later, madam will discuss over this part as well. Any questions from MS7, MS8, MS9?